with implicit functions. So we kind of already defined this as that a horizontal tangent occurs when dy dx is equal to 0. All right, so when the derivative is equal to 0, and we have a vertical tangent when dx dy is equal to 0. So when the rates are flipped. Now, as we have learned, for most all problems, the derivative for implicit functions is typically equal to some function of x and or y, or neither, over a function of x and or y, or neither, on the bottom. As such, and also, I wanted to add something here. And a funny thing happens here. Dx dy actually turns out to be equal to 1 over dy dx. They actually turn out to be just reciprocals of each other, and actually it actually turns out to be true. I'm not going to go over the mathematical ideas. I know I told you not to think of them as fractions. If you did think of them as fraction, you would say, oh, it's just 1 over a fraction, so keep change flip gives you dx dy. Kind of makes sense in that way. It's not really what's going on in regards to the math, but for our sense and purposes, this is true. So what I mean here is that if we were going to try to set dy dx equal to 0, it is analogous to saying f, the numerator, f of xy, is equal to 0. And this is for horizontal tangents. And similarly, if I wanted to find dx dy equal to 0, well, if I flip this, it's analogous to g of xy is equal to 0 for vertical tangent, the denominator. So if you have, so on the AP exam, typically what happens on the AP exam is they give you dy dx. All right. Some problems will give you the implicit function, and they'll say things like, show that dy dx equals blank, and so they'll give you dy dx. I've never seen a problem on the AP exam with implicit differentiation where they didn't give you dy dx. Now, they might also ask you to show that that's why dy dx is, or dy dx is, but note that if you can't find dy dx, okay, you still use what they say is dy dx. You don't go, well, I found this to be dy dx, so I'm going to use this. They're wrong. No. Use their dy dx, and that's how you usually can do part B where you couldn't do part A. So horizontal tangent, we set the numerator equal to 0. Vertical tangent, we set the denominator equal to 0. Now, what this is typically going to do, and this is important, if the numerator or denominator contain both x and y, then finding horizontal tangent slash vertical tangent will find a relationship between x and y. You will always need original function to find the point x comma y when horizontal tangent or vertical tangent exist. And I say this exists part right here because if f of xy never equals 0 or g of xy doesn't equal 0, then this means no horizontal tangent or no vertical tangent. So some problems will actually tell you and say things like, tell me why there's not a horizontal tangent. Tell me why there's not a vertical tangent. And you would say, well, because if I try to solve this. Now, other problems will say, show me why there is a vertical tangent at x equals 1. And so you'll plug in x equals 1 and then it works. So that means you know x equals 1. And they'll say things like, show me why there is not a horizontal tangent at x equals 2. And you plug in x equals 2 and you don't get a solution. Well, Darwin, this is AP Calculus. You can choose to do as much as you can and do. I'm preparing you for the AP exam. I warned you in regards to being in 2 AP exams. It's not a question that you need to bring up during lecture, but I warned you about being in 2 AP courses. All right, going into the material that I have to teach. Back to the material I have to teach here. So there's a lot of ways to word these questions. All right, there's a lot of ways that we can attack in doing these problems in terms of, is there, isn't there, find. It's very important to note that in these problems, at least, I'm going to be giving you the original implicit function as well as the derivative function. So let's look at an example. Now, I'm going to give you both the implicit function and the derivative, because right now I'm not really worried about, my purpose and focus is not on you finding dy dx. My focus is on you doing the concept at hand. So x squared y plus x equals 3, and dy dx equals -1 minus 2xy all over x squared. Okay? X squared y plus x equals 3, with dy dx equals -1 minus 2xy over x squared. And I'm telling you that if we solved for dy dx, if we did the implicit differentiation to x squared y plus x equals 3, we would get dy dx equals -1 minus 2xy all over x squared. So we would get that. I'm telling you that's what you get, all right? Take it as truth. If you want to verify it because you want to do some extra work on the side, you can do so, but that's what the answer is. Okay. Now, typically the problem says B. So typically this is the question on the AP. The question is to find the value or find the coordinate or coordinates for horizontal tangents. That's typically the question that you get. So I'm breaking this problem up right now into a part A and a part B, but typically you just get part B, and then you have to do, you're technically doing both things, all right? So the first thing it's going to say is find a relationship for horizontal tangents. Okay, so please see how you can do this. Please try set up this problem. I'll give you just a very short time to set up this problem. All right, so how do I find the relation for horizontal tangent? What did I just learn, or what did I just learn about where horizontal tangents occur? When I read this, and this is something that we'll do, and as we practice closer to the AP exam, when I see horizontal tangent for implicit, I think what is that I want to write down on my paper? What is the thing that I should know, the mathematical relationship that I have? dy dx equals 0. Okay. But that's just for explicit functions. But what does that mean for implicit functions? So first and foremost, yes, dy dx equals 0. That's what you got to do. If you hear horizontal tangents, you think dy dx equals 0. Now, what does that mean for implicit?
What did I mean? Like the slope for both the implicit and the derivative slope is 0?
Well, we said right here. This is what we said. That's a little slow. So how do I set dy dx equal to 0? Well, the easiest way to just remember is numerator equal to 0. Numerator of dy dx. The numerator of dy dx. Because in implicit differentiation, you got to think of the numerator and the denominator as two different parts, okay? For dy dx. So what do I do? What am I going to write down on my paper to get credit on the AP exam? What is the numerator of the derivative? What is the numerator of the derivative?
-1 minus 2xy.
Perfect. And we set that equal to 0. Now, you can solve for either x or you can solve for y. It does not matter if you solve for x or you solve for y on this next step, okay? But you should always, if you have the option and they are different in regards to how you solve them, I always recommend you solve for the one that is not going to include fractions potentially, okay? In other words, it's you solve for the one you feel more comfortable with. And for the most part, in this problem, it's x times y. So I'm probably just going to solve for y because that's what I typically have done in my previous math courses. So now that this right here is a point on the AP exam. That is a point on the AP exam just by writing that. And then this would typically be like part A is part of it's like a two-part problem. Or three-part. This is typically a three-part point question. You get 1 point for setting the horizontal tangent equal to 0, 1 point for finding the relationship, and then 1 point for finishing it up with that coordinate. And it's that last point which is typically the longest point on the exam. So we're going to solve. When I solve this, I get negative 2xy equals positive 1. And I'll divide by negative 2x, divide by negative 2x, and I get that y equals negative 1 over 2x. And that's what I was looking for. So that's the answer. Okay. Can I just reply real quick? So now that we have a relationship, and now I want to find the actual coordinate. Now I want to have to find the actual answer. With implicit functions, it's always the same. Now, when we do it with explicit functions, whenever we do this, like we did in last night's homework, we always got an answer, like x equals 1, x equals plus or minus the square root of 2, x equals 15. We always got a single answer of x equals because y was explicitly defined as a function of x. That's not always going to be the case here. Sometimes that will occur. Sometimes you will get an answer like x equals this. Now, when finding a coordinate, though, for the previous problems, the next step was always the same, and it's the same here. We always plug back into the original function to find a coordinate. When you want to find the coordinate, you always plug back into the original function, even if no matter if it's implicit or explicit. Okay? If it's implicit or explicit. So, what am I going to do with y equals negative 1 over 2x now that I just told you that? Just told you what to do.
Plug into the original function.
Plug into the original function. What is the original function? Can you repeat the original function to me?
Is it x squared y plus x equals 3?
Okay, and when I plug it in, what is it going to look like?
Do you mean where it's going to go?
Yeah, so yeah, when I plug it in, how am I going to rewrite the next line? So I'm going to plug in, I'm going to follow what we said. So Ariana said I'm going to plug into the original function. So what is that going to look like now?
It will be x squared parentheses negative 1 over 2x plus
Parenthesis,
x
parenthesis, plus.
plus x equals 3.
Perfect. And what do we do with this? We solve. Basically, what happens in all of these problems is typically most all of these horizontal and vertical tangents, I would say 80% of them, in the reality, they're system of equation problems. They're problems that we have two variables and two unknowns, so you need to use two equations. And the first equation is typically the derivative, and the second equation is typically the function. These are two relationships of x and y. This is my first relationship. Well, basically, this is the first relationship between x and y. It shows a relationship of x and y with an equal sign that is true. And then when we found the horizontal tangent, we found another relationship of x and y that also includes 0. Or that also includes x and y.
I have a quick question because I'm still a little confused. When we solve, do we solve for 0 so we would move the 3 over, or do we solve for 3?
Can anybody answer that? Solve for
3?
For x. Now, Farida's question is a little bit differently. Farida is noticing two things, and she's putting two things together. And this might be something you're doing. She sees the x squared. And what she has been taught, and she's been doing lately, is that when you see x squared, you want to get the equation equal to 0 because you're going to involve some type of factoring. Now, that all piece is all algebra, okay? So how you solve for x, can be many different ways depending on the problem. But in the end, we're going to try to solve for x. My recommendation is that first you try to clean it up, and then you try to identify what type of problem it is. Right now, it looks like it's quadratic, but in reality, this is not a quadratic problem. All right, you see that x squared, but when we clean it up a little bit, we won't have it. There will not be an x squared. If the x squared does not go away, in some problems, like on your homeworks tonight, it won't go away. You'll solve it by doing factoring. I have to assign, and I want to make this very clear in terms of the homework in regards to, it was brought up a little earlier. There is the most main purpose of the homework is not the calculus concepts. That has very little to do with it, actually, in reality. It's the algebra. Um, Year in and year out, the majority of students that enter AP Calculus have not had the mastery level of the algebra that they will need to do to just learn the calculus. And this is true across the country. This is true across the world when it comes to AP Calculus. And a lot of the problems are assigned such that I'm really trying to give almost, it seems like I'm giving the same problem, but I'm not, because a lot of the focus is on how the algebra of the solution works out. And we need to A, know how to be able to do those, and B, know how to do those efficiently. And that only comes with practice. The AP exam is a timed exam, and the reality also being that most of you, not all of you maybe, most of you lost some algebra practice. Um, I try to open that up by doing things like the Bridge to Calculus program that helped with that practice of algebra. Um, I even did some stuff with Acellus last year, is getting some extra algebra practice. Um, but a lot of teachers at the very end, the course kind of ended and you really didn't get that practice, or your mentality kind of maybe dropped away from that algebra. So the most important thing, the hardest thing about AP Calculus, as I keep trying to say since the beginning of the year, is it's not the calculus, it's the algebra. And I think a lot of you are seeing that, especially those of you in tutoring. We have that conversation almost daily, right? It's the algebra practice. And by doing this course, I tell everybody that, hey, if you make it through this course and you do it successfully with this course, you're set for life in terms of your algebra and any math course that you can ever potentially do. Not because of the difficulty of the course, but because it meshes new concepts with really, really, really mastering the algebras. And um, it's it's a very hard skill to do, and it really takes hours of practice, with especially throughout the week and throughout this course. So do note that. So let's simplify this. Let's clean this up. What do I get? Now it's algebra. Now it's all algebra. Technically, that was algebra 2. But what do I get? What do I get?
Negative x squared over, actually, x squared over negative 2x plus x equals 3.
Okay, we can start there. That makes it a little cleaner. What does that become?
And then you can change the like the x so the denominators match.
No. You're overthinking it. You're overthinking it. If this 2 wasn't here and this negative wasn't here, I think you can do it.
It would have just been x.
Okay.
But 2's there. So like it would have been what? Negative 1 over negative
Negative 1/2. Negative 1/2. Just bring that constant out. So that's just negative 1 over 2. So negative 1 over 2. And if you
simplify.
Yeah, that's the whole thing. That's what we're saying. I said we're simplifying. We're cleaning it up. Simplifying and cleaning up mean the same thing. I hate the word simplify, entirely the truth, because what is the purpose of that? It's be able to solve this. So we're cleaning this up first before we have to realize what we're doing. So negative. So what you need to be able to see is that this is the same thing as this. All right, these two things right here are the same. All right, and that is an algebra. That's an algebra concept right there. The negative 1 over 2 is just a fraction, and it's the same thing as negative 1 over 2 times 1 over x, and the x squared over x. Now, I've done a lot of practice, so I can typically go from that purple to this new line right here, which is negative 1/2 x plus x. Oops, I don't know why I put a plus, equals 3. All right? But it might take multiple steps of manipulating the problem till we get there. Okay? So, well, now this problem doesn't look that bad. Hopefully it does not look that bad.
So you have two solutions.
No, you do not. What do I get?
X. Oh, x equals 6?
It's going to be, yes. And in the reality, if you can do that math in your head, either because you can just see the answer or you can, how we do algebra in AP Calculus, we're not going to really grade you on showing that algebra work, and I have to see it. So when we're doing it and practicing. But how did you get that? What do you do? What is negative 1/2 x plus x?
1/2.
It's 1/2 x. 1/2 x. You
Three.
You have a whole x. You have a whole pizza. And you subtract half a pizza. How much do you have? Half a pizza. Looks like when you did it when you were first learning fractions. And it's the same thing. We're just saying now, we're going to take away half a pizza, and then we're going to add a pizza. We're going to take away half an x, and we're going to add a full x. Oh, that's 1/2 x. So that's algebra right there. Equals 3, so x equals 6. Oh, wait a minute. Is that the answer?
That's the answer.
That is not the answer. I wouldn't have asked it that way if it was the answer.
Well, that's a solution. So why the next one?
Can someone tell me?
Do we have to put that as coordinates?
Yeah, we have to put it as a coordinate. So what do I have to find as well?
So that's x is 6, so the number is negative 1 over 2x.
So what is it? How do I do it?
So that's complicated. I didn't use the coordinate equation.
Mm-hmm. So what is it? So what do I do?
So it's y positive. Oh, that's a difference.
Ariana?
Well, we know y equals 1 over negative 2x. So our coordinate will just be parentheses 6, comma, negative 1 over 12.
Good. So y, we know the relationship that y equals negative, and how you say it. I mean, Ariana really likes to say the 1 over negative 2x. I like to say negative 1 over 2x. It's the same thing. And so the answer here is 6 comma negative 1/12. 6 comma negative 1/12. Okay. So let's take a look at this. X squared y plus x equals 3. So this is what this implicit function looks like, okay? And we want to find horizontal tangents of when there is a horizontal tangent. Now, if we look to the left of this graph, you can see it's actually always going down, 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 and it keeps just going down. But if we look at the right one, it kind of feels like it's doing the same thing, but it's not. It actually goes down, 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 down. It goes underneath the x-axis, but then it actually starts coming to back up. It goes, if you can, and you can barely tell, but it goes it goes down, and you can see that if I really stretch it here, you can really exaggerate here. You can see that the graph actually, and into the naked eye, or if you're doing this on a graphing calculator, you can't really see this unless you would know where it's at. But the graph actually dips down and then comes back up, and you can see that there's a horizontal tangent, and we found where that horizontal tangent is. It is at the coordinate 6, comma, negative 1 over 12. And if you look at that graph, you can see that there is in fact a horizontal tangent at y equals negative 1 over 12. We can see this is visually what we found. Now, if you were to look at that graph, there was no way you were going to be able to see that happened at 6. You might not have just thought that the whole graph was going down, 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 down forever on the right-hand side. And who's to say you even know what this function even looks like, right? You're like, oh my gosh, I don't even know what that function looks like. There you go. Now, I'm going to run out of time here. I'm going to modify the homework. And what I was looking and doing is I had initially planned, like, I was going to show this type of information within the previous lecture, but then I decided to do the previous lecture explicitly. So I need to modify the homework very briefly. I want to do more practice and more problems on this on these types. So I'm going to modify the homework down, and we'll continue from there. Okay. So pretty cool ideas here. Now, before we leave, and we still have 1 minute left, if I was trying to find a vertical tangent, what would I do? So B.
Well, if you're trying to find the vertical tangent, when you look at the denominator and equal it to 0.
Show why there are no vertical tangents. And I'm going to do this problem real quick. Yeah, so we would set the denominator equal to 0. So this is part C right here. Show why there are no vertical tangents. Well, if I do vertical tangents, I want to set the denominator equal to 0, which is x squared equals 0, right? We're like, wait a minute, there's a vertical tangent. There's a vertical tangent when x squared equals 0. And that gives me x equals what?
0.
0. All right, and then to find the coordinate, I plug that into x squared y plus x equals 3. And that gives me what?
0. So x0 squared y plus 0 equal 3.
Which gives me
3.
0.
No
0, yeah, 0 equals 3. So,
No solution?
yeah, it's not a solution.
There's no solution. There is no vertical tangents. Because remember, in order to be a point, it needs to be a point. So even though we get a solution of doing the work and you get x equals 0, it turns out that x equals 0 is not a vertical tangent, because when you plug it back into the implicit function, there is no such coordinate where x is equal to 0. And we kind of get to see that because, as it turns out, it's not necessarily a vertical tangent. It's a vertical asymptote at x equals 0. So those are the types of things. I'm going to adjust the homework down a little bit and then reassign it. So don't get started on that right away. It's 9:51 though. We do have to end class. I'll see you tomorrow. Take care, everybody.
So, Mr. Agosto, so for Wednesday, it's a half day.
Wednesday is half day.
Half day.
School dismissal is at 11 a.m. And I don't think there's anybody here on student council, but student council is looking to doing stuff with the CAS and some type of thing. So my understanding is that there's not going to be any classes. They have not definitively told any of us teachers what's exactly going on, but that they're trying to do something with CAS or with the school on Wednesday. So I'm just planning on Monday lesson, Tuesday lesson, and then Tuesday's lesson due on the Monday when we get back. That's what I'm doing.
Okay.
For both classes.
Bye.
Take care. Bye-bye.
I'm
Bye-bye.